So it seems that another presenter is presented earlier, so I have to present the last. I'm presenting on behalf of James, who is a recent graduate of MSc Robotics. He couldn't be here. He's working as operation director for one manufacturing company in Dubai, but his interest is in robotics, just like my other students and graduates. They already have MBAs, but they take MSc Robotics anyway. So thank you for joining us. All right, so the challenge here is that we have more than 57 million metric tons of e-waste in 2021 alone. And that's about as heavy or even more than the Great Wall of China combined together. It's very big, right? And it doesn't stop there. By 2030, we will have 30 billion IoT devices. This morning we have heard the keynote speakers, they talk about IoT devices, not only your phones, but all of these connected things, all these electronics will contribute into this landfill. So, but why we have so much e-waste? Well, first is because there's a rapid R&D. When was the last time you upgrade your phone, change your phone? It's probably less than 3 years ago, right? It's very rapid as compared to last time maybe our devices can last for 5 years, 10 years. Now it's very, very quick. Some of them change phone every year, and not only because of this, but also because the limited repair option. Sometimes you have even one component not working, you have to change the whole thing. So you have to buy a new thing. This become accelerate the addition of waste, of e-waste every time. And then COVID-19. What can you guess why is COVID-19 accelerating the pileup of e-waste? Because during the pandemic, we have online learning, we have work from home, right? So naturally, you need more devices. You want to upgrade your internet speed. Maybe you were happy with the 100 Mbps, you want to be half GB or 1 GB, right? Maybe you used to have a 3G phone, was very happy, then suddenly you want 4G, 5G. So these things accelerate the number of electronics that we acquire, that we have, so we have hence more e-waste. Another thing is e-waste is really hard to recycle. And while all these three things are beyond our control, what we are trying to focus here is how to recycle e-waste, how hard it is actually. Well, first it's hazardous because it contains probably batteries. Batteries contain mercury. Some e-waste can emit gases that is dangerous for us. It's complicated because most of them consist of small parts, small devices. You have to tear them apart and then you have to separate them. You have to put plastics over here, metal over here, and other things. Maybe some of them are recyclable, some of them are not, right? So it's very labor intensive. It has to be done by human. That gets us thinking, how well can a robot help to automate this process? Will robot help us or not? If so, how well it is? So we did the research. Actually, this was James' final year project in MSc Robotics, and then we did further research on this. Start with the literature review. We found that yes, there are many attempts on this. There are many attempts on using robot for automating e-waste. So we start to do prototype design and implementation, and then test and analyze. During the literature review, we found that most of the failed attempt is because of the robot cannot locate where is the component. They go to wrong things and then it stops the sequence. Or another hard thing to do with robotics is to have a generalized approach that, okay, just like a human, if I give you a radio model A and then you will be able to tear them apart, next time there's another model I give you, you will be able to tear them apart. Robot doesn't do that way. That's what the literature claims, but we yet to prove that. So we built the system which is like this. So we have an industrial robot in the lab. It's Epson VD6 6-axis robot, and we equip them with a camera, full HD camera, and we pick an e-waste as an example to be disassembled, and we will measure how much time it does, how accurate it is. And we take a smoke detector as a test subject, connected to a computer using a Python and OpenCV, and we have to design a custom gripper to handle this e-waste. The custom gripper needs to have a screwdriver also there. We fit in a motor there. So we have to design the gripper using SolidWorks and Cura, and we attach it on the robot's arm as the end of tools over there. Yeah, so it can open a screw because it has a screwdriver. It has claws that will pick the item and place it at where it should be. So with this, we did the implementation, and let's watch the doom doom doom. Does it work? Okay. So basically, what the video shows, it's a robot. Oh, okay, there it is. Okay. Let's take a look. Alright, so as you can see, the robot performs very well. And on the other hand, we also see that there are some issues that we have not been able to solve it. So for example, it's fast, yes, it is accurate. And its accuracy is amazing because we don't have to teach that you have to place the e-waste in certain way so the screw is always there, because there's a camera that even if you put it like this, it will know where is this screw, so the screwdriver will go exactly where it is. It's pretty accurate. However, if you use another model, or if you take another model of a smoke detector or other e-waste and you put it over there, you will have a problem. For example, you need another training because maybe it was a plastic over here, but in other model it's a metal. So after you pick it up, you have to put it in certain place where it is should be for metal, not for plastic. And you need different jigs for different items. This jig here was developed specifically for this kind of e-waste. If you have an e-waste that is a square or of different dimension, you have to develop another one. It needs different custom gripper tools for different items. For this kind of e-waste, yes, this kind of tool is good, but in other e-waste, maybe it's not useful because the e-waste is so big, so the claw cannot open wider, so we have to develop another one. And there's a high dependency on the robot and camera model. So happen that we have a good enough robot. It's pretty good actually, repeatability and accuracy wise. And the camera is also very good, but sometimes it does misbehave as well under different lighting condition. So during the experiment, if it's on the day, it works fine. In the evening, it works differently because the light is different. Yeah? Maybe it casts shadows from here and there. So yeah, there's a high dependency here. Otherwise, if we can control the environment, it's relatively fast, accurate, consistent, and safe for human because then we don't have to deal directly with the e-waste. Hence, we have this conclusion. Yes, robot can help to automate e-waste recycling to be faster, more accurate, and safer for human. However, there is still plenty of overhead efforts needed to make it work, which is also not cheap. And probably some companies or some countries would still think it's cheaper if I hire people to do this e-waste, or just don't process it, just dump it away. Okay, but to solve that, probably in the future we will do similar stuff with a better GUI, with the error detection. Yeah? Because, for example, if If the robot picks the item up and this item drops, the robot doesn't know. Currently, it doesn't know. So with error detection, it should be able to know that it drops and look for that and pick it up again. Yeah? Currently, it doesn't have something like that. And integration with the artificial intelligence. Currently, it's not artificial intelligence, it's just simple object detection. With artificial intelligence, hopefully we can train the robot, so it doesn't matter what kind of model is this. The robot should be able to adapt itself, for example, by changing the tools. If the item we place is bigger, it changes the tools automatically to a bigger gripper and so on. So thank you for being here. Time for a question and answer, and this is it.